ACT Math Test number 2. Start with problem number 40. As a reminder, these videos go fairly quickly. If you want to use them the way they were intended, you should pause it now, try the problem, and then watch while I go through the solution. In triangle ACB, we have sine of A equals 3 over 7. This is A. Sine of A is opposite 3 over hypotenuse 7. Well, we already know this is 14. This is X. So we've set up a proportion problem. 3 over 7 equals 14 over X. Move this over here. And then we just multiply it. 3x equals 98. X equals 98 over 3. This is a good ACT problem. They're trying to see if you know how to solve proportions and also if you can handle the different kind of trig they're going to throw at you. So, number 41. Which of the following could be the equation for parabola graphed in the standard coordinate plane below? Well, look at your roots. Those are your roots. That means you solve this equation and this equation multiplied against each other. You need to know this from basically working with parabolas before. Now, it could be multiplied by something. Doesn't matter. It's going to be positive because it opens up. Negative would point down. And that's going to equal y. So I'll look for the equation with x plus 2 and x minus 3. Only one is A. Number 42. Average set of 5 integers is 4. One of the integers in the set is 3. What is the average of the other 4 integers in the set? Well, the average of 5 integers is 4. So there's 5 of them. So if we add them all up and divide by 5, we're going to get 5. We're going to get 4. Excuse me. Confusing problem from the perspective of all these numbers. Well, we could make them all 4. 1, 2, 3, 4. 5 of them times 4 is 20 divided by 5 is 4. But it says one of them is 3. So if this one was 3, it's 1 less. This one would have to be 5. Now, get rid of that one and divide by 4. We will get 12 and 5 is 17 over 4, also known as 4 1/4. Lots of different ways to do that problem. That's one of the ways I like to do it. Now, this one I've tried a dozen different ways. I think I finally figured out. One of the solutions is x equals negative k. So if it's a solution, plug it in. 4x, negative x squared minus k times negative k, minus 8 equals 0. And I had looked at this as factoring, and how do you factor getting up to 8. So if you want to do it that way, there's a way to do it. It just gets very confusing with this negative here. So that's why I'm going about it this way. K squared plus k squared minus 8 equals 0. 2k squared equals 8. That means k squared equals 4. That means k equals plus or minus 2. What I recommend doing if you have time is going back and making sure that one's done correctly by checking those answers. If you put in 2 for k, you should get negative 2 as an answer, and vice versa. And that's again why I said it's confusing with this negative up there. This one, straight out of geometry class, you got triangle T1 congruent to triangle T2, which is similar to triangle T3. Now, this could also be the same, because if something is congruent, it's also similar. So triangle T1 must be congruent to T3. No, it could be that situation, so definitely not that. Triangle T2 must be similar, yeah, to triangle T3. It has to be, because if it's congruent to T1, then it's also going to be similar to T3. So this one's a good. And triangle T1 can be congruent to T3. Well, that's what I was saying here. It might be the same. Congruent items are similar. So it's 2 and 3. It's kind of an ugly problem. Designed to trip you up, no question about it. All right, I'm going to read this and then pop down there. George is building blocks. He wants to make 1.5-inch blocks. He's got 6-foot long board, which is 72 inches. Convert everything to the same units right away, and I'm going to work on this one over here. Problem is, every time he cuts, he knocks out 1/8 of an inch. So if you looked at the board this way, he's got his 1.5 inch, and then he's got his, and I'm drawing it not scale, 1/8 of an inch, then 1.5 inch, then 1/8 of an inch, 1/8 of an inch, so on and so on. So basically, you're going to say, how many can I get if I divide by that? You got to put parentheses around the bottom, blast it all out. I'm actually going to use a calculator because I don't see a simple way to do that. I get 44.3. So it's going to have a little chunk of wood left over. It gives us B, 44. $46. What's the value for K where these lines intersect at the point? Well, if they intersect, they're equal. Now, they happen to give us X and Y, but I don't really need Y. I only need the X value. So K times 4 plus 1 equals 4 minus 2. 4K equals 1. K equals 1/4. This is a good one to check, especially if you're quick with the calculator. Plug that 1/4 back into both equations. Oh, well, into the first equation, put the X in, see if you get 2. Which you do. Pretty straightforward, so works quite nicely. 47. Equation of a line containing one side of a rectangle. Ooh, I hear about an equation. I better graph something. Down 2. Up 4. So we've got some sort of rectangle, some shape like that. Slope of this line is 3/4. So it says, what's the following equation of an adjacent side? Well, these are perpendicular. That's what makes them a rectangle. Flip it and throw a negative out front. So which one has a slope of negative 3/4? Nope, 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 nope. Yep. And I have no idea where the negative 4 came from. I don't care. I'm just dealing with the slope. How many positive integers are factors of 30? This is a pre-algebra question. Usually earlier in the test. I'm a little bit surprised to see it here. Well, 1 times 30, 2 times 15, 3 times 10, 5 times 6. 1, 2, 3, 4, 5, 6, 7, 8. Done. Most people find the wording on question 48 to be challenging. That's why you're doing practice problems. So when you see it, you know what's coming. How many positive integers? Positive integers. These are all integers. They're all positive. Don't have to worry about negative 2 times negative 15. Not going to happen. This is a challenging problem. Tripped me up first time I did it. Rectangle with diagonals AC and BD intersecting E are shown below. To square if and only if triangle ABE is congruent to which? Well, if ABE is congruent to ACD, no, that makes no sense. And I'm going to change colors so I can draw them all in. That first one was this one. That doesn't make any sense. ADE, that might make sense. BAE, that's the same one. BDC, I'm going to erase these so I can see what I'm doing. BDC, no, that doesn't make any sense. And CDE, CDE, no, if it's congruent, it is already congruent in the rectangle, so it can't be these. So that only leaves me with B, which is correct. I don't like this problem. It's kind of just a feel it out sort of thing. I know we're at the high 40s, so we're supposed to get problems like that in the ACT, but I still don't like it. School supply store sells pencils and pens. Let's call pencils X, so 2X plus Y is 0.55, and let's call pens Y. And then over here, 2Y and 1X equals 0.95. Let's multiply by, oh, what the heck, -2 down here. Now I'm going to do it in my head because I don't have enough room on this stupid page. Those are going to cancel. Y and -4y is going to be -3y. I need the calculator to make sure I do this right. Actually, I don't. It's going to be negative -1.35. And finish that out. I get y, which if you recall is pence, and I should have written it down, but again, I don't have a lot of room, is 45 cents. So if this is 45 cents, the next has to be 5 cents. So together they'd be 50 cents. Now, notice that there wasn't a lot of room to do that problem. That's because I typed these in 2 columns. The ACT is only in 1 column, just to save space. So my printing costs aren't up through the roof. But that's basically how you do it. Wouldn't be a bad idea to do some guess and check on that one if you want. 51, imaginary number I is square root of -1. So this is a beautiful problem because you look at it and go, there's no way I can do this. Well, you get I plus I squared is -1 plus I to the third is -I plus I to the fourth is 1. Cancel, 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 cancel. So the first 4 add up to 0. The first 8 add up to 0. The first 12 add up to 0. The first 44 add up to 0. The first 48 add up to 0. So the next one is I to the 49th, which is just I, because the whole I through 48 is 0. Can be left with I. You're done. Would not expect you to know how to do that problem unless you've played with imaginary numbers before. Very challenging. But if you've seen it and you play with it, it's not too bad. This one's similar. This is an ASTC problem. If you've taken trig, this means all sine t cosine. It means everything's positive, only sine is positive, and cosecant, but we're not going there. Tangent is positive, cosine is positive. So where is sine positive and cosine negative? Well, that's up here. And 0, 2 pi is once around. Half of that is pi. Half again is pi over 2. This is 3 pi over 2. So we're looking at the second quadrant between pi over 2 and pi. If you haven't taken a class in trig, that's virtually an impossible problem. What is the area in square centimeters of the larger circle that can fit within a 6 by 8? 6 by 8. Well, we're wasting 2 over here. I'm going to try and draw that a little better. Because we're going to have a circle that just fits in a 6 by 6 square, which means it's got a radius of 3. And the area is pi times 3 squared is 9 pi. I screwed this one up the first time I did it. I went with a radius of 6 and ran off. Fortunately, they didn't have 36 pi in the answer, so I got a little lucky. Circle the radius of 6 inches is cut into 12 equal pieces. Well, radius of 6 inches. That means the circumference is 2 pi times 6 is 12 pi. It's cut into 12 equal pieces, so each piece is 1 pi. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pi. Okay. What is the measure of the arc in inches? Well, I just did it. It's 1 pi. Don't get fooled into picking that one. Another one that would help if you had done trig, 54, and then another one, 55. If you've ever put something in standard angle, that's what all this verbiage means. It's just saying it's standard angle, which means it starts here and it goes here. So what is something that's coterminal with that? Well, you can either go forwards or backwards. Backwards would be -320, and that is coterminal. We're asking which one is not coterminal. 400 be once around 360 plus 40. 400 works. Once around is 360. Twice around is 720. 680 is probably our answer. I just said twice around is 720 plus 40 is 760. And 1120 does the same thing. So 55 is C. So 56. Pardon me. Airplane flies for 8 hours at X miles per hour. So X miles per hour times 8 hours gives me the amount of miles it goes. So it goes 8x miles. Then it did 7 at 325. So 7 times 325. That's how many miles it's gone. And it averaged 350 miles an hour. So which is finally going to be used to find x? Well, it went 8x plus 7 times 325. It did that for 15 hours. So that's its average speed. And that equals 350. So we go 8x plus 7 times 325 equals 15 times 350. And then we say, well, that's it. I was going to solve it for x, but that's all they want us to do. 8x plus 7 times 325 equals 15 times 350. Okay. Very challenging problem. You have to play with rates to understand that one and make sense of it. Okay, problem that totally caught me off guard, and then I remembered what I told everybody. I'm not going to even read the question. First thing I do when I see a quadrilateral is draw a height. These are trapezoids. These are trapezoids that are lying on the ground. So this piece is 2, and I cross it out, and I write 5, and I cross that out, and write 2 and 3. And then I go, oh, wait a minute, I know what's going on here. That's a 3, 4, 5 triangle, because it's a right triangle. And that's a 5, 12, 13, because it's a right triangle. So it says, go back and read the question. What's the area of the little one to the big one? So I can definitely cross out this because it's little to big. Well, the area is, you know what, I'll do it the long way. Area of ABCD is the triangle, which is 3 times 4 times half. 6 plus 2 times 4, 8 equals 14. And CDFE is 5 times 12 is 60 divided by 2 is 30. Plus 12 times 2 is 24. 54. That doesn't feel right. Yeah, but it looks right. And what's the ratio? 14 over 54 is 7 over 27. Without seeing the triangle relationship, you can't do it. It's impossible. Good problem. Challenging problem. Late in the game problem, but a good problem. 58 I'll let you read. And if you've ever played with parallel lines, you get this. A and B add up to 80, 180. These are parallel, but they're not parallel. So the lines are going to eventually meet all the way out here. So this one's opened up a little bit bigger. So I know that A plus B, instead of equaling 180, are going to be greater than 180. That's what it's asking. You have to play with parallel lines and same side internal angles. Same side angles are supplementary and all that fun stuff. 59, very tricky problem. Let's remember what the area of a circle is. It's x minus h squared plus y minus k squared equals a radius squared. I don't know the radius here, but I do know that this is one half an equation and this is the other half. So I'm going to do them both. I'm going to go xy, 1 minus 2 squared plus a minus negative 3 squared equals, and I'm going to do it again, a minus 2 squared plus 3 minus negative 3 squared. Now I'm going to go do some math. 1 minus 2 is negative 1 is 1 plus a squared plus 6a plus 9. A squared minus 4a plus 4 plus 3 plus 3 is 6 squared is 36. Cancel. 10a equals 40 minus 10, 30. A equals 3. So, last but not least, if a and b are real numbers, such that a squared doesn't equal b squared, in other words, a and b are not equal, nor are they multiplicative inverses of each other. I think that's correct. What's true of this equation? Well, for absolute value equations, you got two choices. Either nothing is weird about it, in which case you would get ax plus bx equals a minus b. Excuse me, that's ax minus bx. You get x equals a minus b over a minus b, which is 1. Or you get negative all of that, in which case you get negative a equals that, in which case you get negative x equals a plus b over a plus b, which is 1. X equals negative 1. So it could be 1 or it could be negative 1. Good way to check this is just throw in some numbers and try. Try 1, try negative 1, see where it takes you. Just realized that my lettering came off on this. It's supposed to be FGH, J, K. So I'll fix that on my hard copy, but make sure I'm correct on the test, on the answer key here. And that's about it. Good luck.